There is a world out there that looks almost exactly like home. A blue and green orb orbiting a sun-like star at almost the exact same distance as Earth orbits our own sun. It has been called Earth's cousin, Earth's twin, and Earth 2.0. But the reality of Kepler 452b is far stranger and more humbling than any of those nicknames suggest. Kepler 452b sits 1,400 light-years away from Earth. To understand what that means, consider this. The farthest any human-made object has ever traveled is roughly 24 billion kilometers. That's Voyager 1, launched in 1977 and still going. Kepler 452b is 800 million times farther than that. If you drove there at highway speed, you would arrive sometime around the year 900 quadrillion. So for now, everything we know about this world comes from a single instrument pointed at a tiny patch of sky. That instrument was the Kepler Space Telescope. Launched in 2009, Kepler was NASA's first mission dedicated entirely to one question. Are there other planets like ours out there? It stared at a fixed region of the Milky Way containing over 150,000 stars simultaneously, watching for the faintest possible signal. A planet passing in front of its star and dimming the starlight by a fraction of a percent. That method is called the transit method, and it is extraordinarily difficult. Detecting Kepler 452b this way is the equivalent of watching a fly crawl across a car headlight from 10 miles away and measuring how much the headlight dims. Kepler 452b orbits its star every 385 days. Earth orbits the Sun every 365. It sits inside what astronomers call the habitable zone, the band of orbital distance where liquid water could exist on a planet's surface. Not too hot, not too cold. And its star, Kepler 452, is a G-type star, the same classification as our own Sun. It is 1.5 billion years older than our Sun, slightly brighter and slightly warmer, which means that Kepler 452b has been sitting in the habitable zone of a Sun-like star for about 6 billion years. Earth has only been doing that for 4.5 billion. Whatever is on that planet has had 1.5 billion years longer than us to develop. Now here's where things get complicated and where the mystery deepens. We don't actually know what Kepler 452b looks like. We can't see it directly. Everything we know is inferred from the mathematics of light. What we do know is that it is about 1.6 times the diameter of Earth, which makes it what astronomers call a super-Earth. And that one number changes everything. Because size is the difference between a world that feels like home and a world that would crush you. A planet 1.6 times wider than Earth could have roughly 5 times our surface gravity. That means if you weighed 80 kilograms on Earth, you would weigh closer to 400 on Kepler 452b. Every step would feel like carrying 4 other people on your back. Your heart would have to work 5 times as hard to pump blood upward. Over time, the human body simply could not survive it. But there's another possibility. If Kepler 452b has a thick atmosphere and is more gaseous in composition, more like a mini Neptune than a rocky world, the surface gravity could be far lower. The problem is we simply don't know which one it is. We don't yet have the technology to measure the mass of a planet this far away with enough precision to answer that question. What we can reason about is its future, and by extension, our own. Kepler 452 is aging. Like all stars, it is slowly growing brighter and hotter as it burns through its hydrogen fuel. Scientists estimate that Kepler 452b is approaching the inner edge of the habitable zone. The extra heat from its aging star is likely beginning to trigger what's called a runaway greenhouse effect, the same process that turned Venus from a potentially habitable world into a pressure-cooking hellscape with surface temperatures hot enough to melt lead. In other words, if Kepler 452b ever had life, it may be in the process of losing everything right now. And in about 1 billion years, the same fate awaits Earth. Our sun is also growing. The habitable zone is slowly drifting outward. Kepler 452b isn't just Earth's twin. It may be a preview of Earth's future, a window into what our planet will look like when our own sun begins to age out. That is why astronomers care so deeply about this one world out of the thousands of exoplanets we have found. It is not just scientifically interesting, it is personally relevant. Kepler 452b is essentially running the same experiment as Earth, just 1.5 billion years ahead of schedule. The next generation of space telescopes, instruments like the James Webb Space Telescope and the proposed Habitable Worlds Observatory, may one day be able to analyze the atmospheric chemistry of planets like Kepler 452b. If we detect oxygen, methane, carbon dioxide in the right ratios, that would be what scientists call a biosignature, chemical evidence that something alive is processing that atmosphere. We haven't found that yet, not on Kepler 452b or anywhere else. But we are getting closer to being able to look, and when we do look, really look, at a world this similar to our own, orbiting a star this similar to our own, the answer we get back may be the most significant thing our species has ever learned. For now, Kepler 452b remains a pale inference in a sea of data, a world 1,400 light-years away that we cannot touch, cannot visit, and cannot fully see. But we know it's there, and for the first time in human history, that might be enough to keep us up at night.